In this video, we will solve this integral right here, and so let's begin. So the first thing that I will do is try to factor out the denominator. If I say x squared plus 1, close parentheses, and x squared minus 1, close parentheses, this will equal x raised to the fourth minus 1, and let's check. X squared times x squared is x raised to the fourth. X squared times negative 1 is negative x squared. X squared times 1 is positive x squared, so negative x squared plus positive x squared is 0x squared, and then 1 times negative 1 is negative 1, so they're equivalent. Next, I will factor out x squared minus 1, which will be x plus 1 and x minus 1. From here, I can cancel out x minus 1, and so I would get the integral 1 divided by x squared plus 1 times x plus 1. Next, I will do partial fraction decomposition. And so the term that has an x squared plus 1, we say ax plus b. If it doesn't have a squared by it, we say c. So we have ax plus b divided by x squared plus 1 plus c divided by x plus 1. And if you're not familiar with partial fraction decomposition, I would go ahead and pause this video and try to watch a video on partial fraction decomposition. I made a video a while ago on this topic. Okay, so after we do this, we need to eliminate the denominator. If I multiply everything by x squared plus 1 times x plus 1, this would cancel out this term, and so I would get 1 is equal to ax plus b times x plus 1, because again, I'm multiplying everything by x squared plus 1 times x plus 1. Then we get plus c times x squared plus 1, because here I just have an x plus 1, and so if I multiply this term right here by x squared plus 1 times x plus 1, our x plus 1 cancel, and we just have the x squared plus 1. Next, I need to try to solve for a, b, and c, and so one way to do this is if I say that x is equal to negative 1. If x is equal to negative 1, this term right here becomes 0. So I would get 1 is equal to 0 plus c times 2, so c is equal to 1/2. Next, I would say that x is equal to 0, and so I would get 1 is equal to, this term right here becomes 0, plus b is positive, and then this is a 0, so 0 plus 1 is 1. So I would get b times 1 plus, we know that c is 1/2, times this term right here is 0, but this is 1, so times 1, and so we would get that b is equal to 1/2. Next, if I say that x is equal to 1, then we would get 1 is equal to, this becomes a plus, we know b is 1/2, close parentheses, this is a 1 plus 1, we get 2, plus c we know is 1/2, close parentheses, we have 1 plus 1 is 2, so we close parentheses here, and then we can distribute this 2. So we would get 1 from here is equal to, we distribute the 2, we get 2a plus 1, 2 times 1/2 is 1, plus 2 times 1/2 is 1. So now we have 1 is equal to 2a plus 1 plus 1. This is positive 2. Move it over here. We get negative 1 is equal to 2a, so a is equal to negative 1/2. So now we simply replace what we had earlier with a, b, and c. We now know that a is negative 1/2, we know b is 1/2, and we know c is 1/2. Next, we can split up this integral into 3 parts. One part will be negative 1/2 x divided by x squared plus 1. The other will be 1/2 divided by x squared plus 1. The other will be 1/2 divided by x plus 1. So we have 3 integrals. Now we need to solve each integral. The first one, we will have to use some sort of substitution. If I say that u is equal to x squared plus 1, then du becomes 2x dx. And so the integral of x divided by x squared plus 1 dx will become 1/2 right here, goes to the front, 1/2. If you know this x will cancel with this x, so I would get the integral 1 over u du, which becomes 1/2 ln u. And so replacing u with x squared plus 1, we get 1/2 ln parentheses x squared plus 1 plus c. Now it's very important, what I just solved for was the integral x divided by x squared plus 1 dx. But here I have a negative 1/2 in the front, and so I need to move this negative 1/2, and I need to distribute it here. And that's why I would get negative 1/4 ln parentheses x squared plus 1 plus c for this term right here. Now the other 2 integrals are pretty simple. We don't need to use any substitution. They are particular rules. because 1 over x squared plus 1 is tan inverse x. We have a 1/2 in the front, so 1/2 tan inverse x. Likewise, 1 over x plus 1 will be ln the absolute value x plus 1. We have a 1/2 in the front, so put 1/2 in the front, and then plus c. So this right here will be our final answer, and that's all we need to do for this problem.